So
Leave the cabbage.
just pick one, 2 viewers, and just evaluate. One will be our experiment. Second one will be okay. Got not that much water. How do you do with this? I want one of you to blow into this to add carbon dioxide. But when we breathe in oxygen, we breathe out, add carbon dioxide. So we're now analyzing by adding carbon dioxide into water. Keep going, more, keep going, more.
You're putting carbon dioxide into the water.
So, there's one interesting thing about cabbage juice is in it we have this pigment. And this pigment, well, keep going.
Smells horrible.
Smells like cabbage. So the first, actually the cabbage, in normal water, it's like pH of 7, which is just normal. By blowing into this, we're just adding carbon dioxide. And this pigment changes color depending on the acidity of the and here we got
cabbage juice.
yeah, actually it's smaller pigment in it, but it's also involved in any other red vegetable. Yeah, especially in cabbage. It's really great for us. Because actually the more let's say pink it becomes, the more acid it becomes.
Okay.
So just keep on blowing.
Keep blowing, Luca. You're changing its colour.
Yep. Still need. You can better see with this one. It's just water and cabbage. No one's blown to it. It's more water, so it's easy to see.
Making it go pink.
And so, which one's more pink? Yes, the one you're blowing. So the cabbage juice indicator is telling us that it has become more acid just by blowing to it, just adding carbon dioxide. So what did happen? Sorry? Actually, there was a chemical reaction going on all the time. So we got water, and we just added carbon dioxide into it. Actually, those two react in water to carbonic acid, and this is quite unstable, and it will just cause the other reactions. This is one of the products of the reaction, so we're actually adding a lot of hydrogen ions into it, basically photons. And those ions are directly responsible for the acidity of the solution. Okay. So actually, carbon dioxide will turn into acid when there's a reaction with water. But actually, you can blow more into it, it won't change because it all have reacted, so it can just stabilize. It will stabilize. But normally it goes to a pH of 6, even sometimes 5.5. Which in our modeling is not cause much effect. But we have to think this as a modelization of our oceans, at ocean scale. And actually what's happening right now is a lot of carbon dioxide into the ocean, actually reacting with water, and then with this reaction making the ocean more acid. And this has a huge impact on the environment, on the ecosystems. Because the ecosystems can only manage this very small shift, very narrow shift of pH. pH is actually the quantification of acidity. And that's also one of the reasons with corals, because corals especially have a very tiny, they're very sensitive to those changes. That's one of the reasons of the corals dying out. Is actually those carbon dioxide. So we might think carbon dioxide greenhouse effect? Yes. But also acidification of oceans, which is quite a big deal.